Today we will discuss about sweepline algorithm. This is a basic algorithm used to solve geometry problem in competitive programming as well as math. Okay. First, we given n lines of A, B, A which is a starting point and B which is the end point of the line. So our target is to find the largest number of lines that intersects. For example, we have 5 lines here. So I'll draw out 5 lines. The first line is 1 and 2. 1, 2. The second line is 11 and 12. Over here. The third line is 5, 9. 5, 9. Oh. 9, 5. The fourth line is 6 and 10, from 6 to 10. Oh. Yeah. From 6 to 10. And the last one is 4 to 7. Yeah. Here's 7 and 4. So the most part that intersects is here from 6 to 7. Okay, from 6 to 7 because it intersects 3 lines. Yeah, this one. This one. Okay, so yeah. Our algorithm will find the largest number of lines that intersects the most. Okay, so yeah, we will discuss the algorithm. Yeah. First of all, there are 2 ways to solve this problem. First one is use segment tree. For each line, you make a query from the segment tree has starting value as 0, 0, 0, 0. Okay, and it has the size of the largest integer in the set of n lines. So for example, with this example, the size of the segment tree will be 12 times 4. Okay, we initialize the segment tree of 0 value of 0. And then for each line, we query a segment. We query a segment, and using lazy propagation, we'll increase the value. Like for example, okay. For example, we have segment 1 and 2, so we'll query like not really query, like we set the segment. So 1 and 2, for example, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, starting with 0, 0, 0. Okay, for the first one, we we set the value of from 1 to 2 is 1. We increase the value by 1. Okay, and then the second one is we increase the value from 11 to 12 by 1. Okay, and next one we increase the value from 5 to 9 is 1, 1, 1, 1, 1. 6 to 10, 6 to 10 is 2 right now. 2, 2, 2, 2, and 1. Okay. Increase the value by 1, 2 by 1. And from 4 to 7, we increase the value by 1. So it will be 1, 2, 3, 3. So this is the largest segment that intersects, and we use segment tree, and the time complexity will be n log n. Yeah. But here the disadvantage of the segment tree is that if the we can initialize the large array. For me, what is large? Large is like you can't create an array like 10 to the power of 9. Okay, you can create the array of 4 times 10 to the power of 9. It's invisible. So we will discuss Swift line algorithm. Yeah, that will tackle this problem with the same time complexity as segment tree is n log n. Okay. So okay, discuss. Erase it. Alright, the example 5, 1, 2, 11, 12, 5, 9, 6, 10, 4, 7. Okay. Okay. First of all, for each line, we'll solve the problem with in the easy way, like the end point of each line is yeah, it's different. Yeah, it's pairwise different. Yeah, like we can have a line has the value like 7, 8, because 7, 7 is duplicate. So we only solve it like it's pairwise different. So the algorithm started as we each line has 2 endpoints, right? Each line has 2 endpoints. So we take 2 endpoints, and then we for each line we take 2 endpoints, and then we push it into the we push it into the array, and then we sort on the point. We sort every endpoint, but we yeah, but the important thing is here we must save the value of lines. For example, like I have line 1. Line 1 has 2 points, like endpoint 1 and endpoint 2. So I'll save the line 1 as line 1. I will save it to the structure. Okay, the struct. Like this is a struct of point. Yeah, for each point there will be a struct. Okay, yeah. Okay, so here we'll save the point. This is the value that we sort. Okay, we used to sort, and then we save the left one, and we save the right one, and then we have to have one Boolean variable is left. Why is left? Because for each line we have 2 points, and that point 1 is the left point, and point 2 is the right point. So if there's a point 1, we'll have 1, 1, 2, and is left 1. Okay. For point 2, we have point 2, 1, 2, and 0. Okay. Easy, right? Okay, I will save. Okay, where will I save the struct? Okay, I will save the struct down here. Point, left, right, and is left. Yeah, this is our structure, our point structure. Okay. Good. After we have save every point for each line to the structure, we'll start it into the array, and then we sort the array according to point. Okay, it's easy, right? We sort the array according to point. So yeah. The algorithm will start from here, like we have 1, 2. Okay, consider I'm drawing the array, an array of points for each line. So the first one, the first value of the array will be 1. Okay, will be 1, and then the second value will be 2. Okay. For easy to okay, it's 2. It's 2. It's 2. This is the dot one is the starting point, and the second one is the plus one is the point. Okay. And the second one is 4 and 7, right? 4 and 7. 4, 7. Okay. Oh no, 4, not 7. Okay. And the next one will be 6, because 6 is the starting point. So here 6. Okay. Next is 7. Start with next is 9. 9 is the end point. Wait, where's 5? Okay. Sorry. 5, 5, 4, 5, 4, 5, 6, and then 7. Sorry. 7, and then 9, 9, and then 10, and then 11, and 12. Okay. Okay, outline will be like this. Starting point to the plus point. Okay, this outline. So we'll traverse to the array. Traverse the array. First, let's take a look at 1. We meet the value 1. Okay, we meet the value 1. But 1 is left, because it's a dot. 1 is left, is true. So we push this point. We push this point into a set. We push this point into a set. So for you guys don't know, set is a balanced binary tree. It's like a binary search tree, yeah. Binary search tree, and it can it can search for element in log n time and then insert an element in log n time. Okay. Yeah. Okay, we push it into the set for like 1, because 1 is the left one, so we push 1 into a set, so our set will contain 1. Okay, and the second one is 2, because 2 is the right, 2 is not the left side because it's a plus sign, so we will check because 2 here, because this point 2 because this point 2 here has the structure like this, point left right is left, so the point 2 will we can know the left value of the point 2, but and the left value of the point 2 is equal to 1, so we erase 1 from the set. Yeah. We erase 1 from the set. We erase 1 from the set, and now our set is empty, and then we'll initialize. Okay, I'll write a pseudocode for you guys to easily to understand. Okay, so sort and then chambers for each I in set in array. Okay, for each I array, if is left I, then push to S, push I to S, push I to a set, else erase I from set, and then we we maximize the answer. Res equal to max res is the maximum value between res and size, s size, set size plus 1. Okay. Okay, for example, like we take the value 1 because 1 is the left one, 1 is the left side, so we push 1 to the set. This is set 1 to the set, and then we take 2 because 2 we know the left side, erase the left of I, not left I, not erase I, we erase the left of I, so here's 2, we know the left one is 1, the left one of 2 is 1, so we erase 1, and then we maximize the answer by res. Result will be the size of set plus 1, so it's equal to 1, and here only one line, 1 2. Okay, so it intersects itself, so it's 1. Okay, next one is we take 4, we push 4 to the set. Next we push 5 to set because 5 is the starting point, and we push it 6. And then here come we with 7 here. Okay, 7 here because we save the value of left, so we know what we will delete. So 7 here, so we'll delete 4 because we delete the left of 7, so we'll delete 4. So the set size remains 2. So we maximize the rest size. We maximize the set size. It will be 2 plus 1 is 3. Okay, 3. Okay, Now the set contains 5 and 6. Then we we consider the value 9. The value 9, because the value 9 we know the left one, so we'll erase the left of 9 is we erase 5. So the set size will be 6, and then the result will be maximized. So 1 plus 1 is 2, and the maximum between 2 and 3 is 3. So it's remain unchanged. So next is 10. 10, we know the value of left is 6, so we erase 6. Yeah, okay. So the set size comes to 0. 0 plus 1 is 1. Maximize the 1 and 3. It will equal to 3. So here we push 11. We push 11 to the set. Push the 11 to the set, and then we push 12 to the set, and then consider 12. 12, we know the left side of 12 is 11, so we erase 11, and then the set side remains 0. No. Yeah. Okay. So the result will be maximized between 1 and 3. So the answer will be 3. Okay. Yeah. Yeah. That's the algorithm. Yeah. Okay. Result will be 3. I will draw a picture and then describe again for you guys to see it clear. 1, 2, 1, 2, 4, 5, 4, 5. Oh no, 4, 7, 4, 7, 4, 7, 11, 12, 4, 7, 11, 12, 6, 10, 6, 10, 5, 9. Okay. Okay. First we take 1. We push 1. So we know the sweep line of 1. Yeah, this is the sweep line. Okay. This one is the sweep line. Then next we come to 2. The next sweep line is over here, and then we know the pair, the line, so we delete the line. Okay. Next we push the 4. This is the sweep line, 4, and then 5. Yeah, and then 6. Okay, 4, 5, 6. Because 4, 5, 6 is a 3 line, 3 starting point of the line, 3 starting point of the line. Okay. So the next endpoint, of each of 3, yeah, randomly like this is the next endpoint. So if this is the next endpoint of this one, so the intersect value will be like, yeah, it will always be like 3. Yeah, for example, yeah, 3, 3, 3. Yeah. So if we take this value 7, this is the endpoint. This is the endpoint and also the sweep line. So we only have to erase the line of 4 and 7. Yeah. Erase 4 and 7. So we have only 5 and 6 as the starting point. So we take 9 here, 9 here because 9 is between here. Yeah, 6 is between 5 and 9. So the the intersection one will be 2. Yeah, 2. And the last one is 1, 6 and 10. Okay, that's this workline algorithm. Yeah, because we use set. We use set. So we'll only consider the number of the coordinates on OX is pairwise distinct. Okay. Yeah. Thanks for listening.